Good morning. Welcome to your third lesson for e-learning. Today we're going to look at the derivatives of the trig functions. So we'll go through all 6 trig functions, find their derivatives in different ways, do a couple practice problems, and that'll be it for the video. Hopefully you can just do this in one video. So for the first 2 problems, I'm going to have you guys use the limit definition of a derivative to find the derivative for sine x and cosine x. And I want to point out that we're going to use these 2 identities we learned in the limits unit. I'm actually going to take the second identity, cosine h minus 1, and rearrange that to 1 minus cosine h. If you remember, we kind of used the graph on Desmos to check that identity to see if you could rearrange those terms, and it does work. So you're going to use the limit definition of a derivative. That's the f of x plus h minus f of x over h, the limit as h approaches 0 of that function, and see what you come up with. So if you want to just pause the video and try that, you can. I'll wait a few seconds and then I will pull down the slide to get you started. If you need to see the first slide of that worked out, that's what that would look like, and then you can pause your video and try to work out the rest. I'm going to work out the rest of it now and see if you get the same thing. So I start with sine of x plus h minus sine x over h. Use the sum identity, sine of x plus h is sine x cosine h plus sine h cosine x. I'm going to rearrange that so that the sine x's are the first 2 terms. Then we're going to factor out a sine x. So now I have a sine x, parentheses cosine h minus 1. Then I'm going to split up my limit into 2 fractions. And you can see in each of those fractions that you'll have one of the identities from above. Write it all out with limits and then plug in your values. So you wind up with sine of x times 0 plus 1 times cosine x. So if your function is the sine of x, the derivative is cosine x. We do the same thing for y equals cosine x. So you can go ahead and pause, or I'm going to go ahead and pause. No, you pause. Yeah, that's how it works. It's early. You pause and work out the video. Man, I can't talk. You pause and work out the limit definition. I'll keep making the video. It's going to be rough. So I set up my limit definition. Cosine of x plus h minus cosine x over h. Then I use the cosine sum identity. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. I'm going to move that second term again, or the blue term. So I kept it in blue to make it easier to see, like all I'm doing is rearranging there. Factor out the cosine x. Same thing I did in the last one, split up the parentheses. And if you need me to go back through that with you one-on-one, just let me know during one of the chats, and I'll definitely do that. But the derivative of cosine x is negative sine x. So then the question is, what about the rest? Well, instead of doing the limit definition for all 4 of those, I'm actually going to do the quotient rule 4 times. So again, you can pause the video and work out the quotient rule for each of these. I'm going to put 1 on each of the next slides so you can check them as you go. So if I start with tangent, which is sine divided by cosine, the derivative of tangent is secant squared. If I start with cotangent, which is cosine divided by sine, my derivative is negative secant squared. Oh, I made a mistake somewhere. Let's see. Derivative of tangent is secant squared. Derivative of cotangent is cosecant squared, negative cosecant squared. Let's fix that. All right, so derivative of cotangent is negative cosecant squared. That's better. Derivative of cosecant is negative cosecant. times cotangent, and the derivative of secant is secant times tangent. So negative cosecant, cotangent, positive secant, tangent. All right, a couple problems. So first one, I think we're only going to do 3 maybe. F of x equals sine 2x. So actually work this one out 2 ways. You can pause it and try it yourself. The first way I did was just the chain rule. So sine of 2x. So there's a sine of something. So the derivative of sine is cosine. And then the derivative of the inside function. That inside function is 2x. The derivative of that is 2. So sine of 2x becomes cosine 2x times 2, or I put the 2 in front. So again, that's the chain rule. Your book uses u for its notation for that a lot of times, so the sine of u is equal to cosine of u times u prime, where u is a function of x. You could also do that by rewriting this with the identity. Sine 2x is 2 sine x cosine x. So then the derivative of that, I'm going to use the product rule. So the derivative of 2 sine x is 2 cosine x times cosine, plus the derivative of cosine is negative sine times the original, 2 sine. So I can factor out a 2, and I have a cosine squared minus a sine squared, which is really just a cosine double angle identity. So I can work that out. All right, tangent to the fourth of 3x. This is my Inception problem. Many of you may not have seen the movie Inception with Leonardo DiCaprio. It's rated R, so you shouldn't see it until you're older, definitely. But the premise of the movie is that Leonardo DiCaprio and his teammates, his crew, whatever, they can go into someone's dreams and they can steal information, or they can implant information. So the idea of the movie is, could you implant something in your subconscious that would then have repercussions when the person wakes up? So in order to do that, they have to go into different levels. So they go into a dream within a dream within a dream. Yeah, so this is like a threefold chain rule problem. I have tangent to the fourth of 3x, which is something to the fourth power. Well, the something to the fourth power, the derivative would be 4 times something to the third power times the derivative of the something. Well, the something is the tangent of something else. So the derivative of tangent of something else is secant squared of something else times the derivative of something else. So all that to say, we could do this. So I start with my outer function. My most outer function, might not be easy for you guys to see, is something raised to the fourth power. So that's going to be 4 times something to the third. So that takes me through this part, 4 times something to the third. Then I have to do the derivative of tangent of something. So tangent of something is secant squared of something. And then the derivative of the something is just the 3. Okay, you could look at this as a giant composite function with the chain rule, so that's what this says. If I separate all these parts, I have x to the fourth. Derivative of that's 4x cubed. So that's what it did in yellow, except that x is really tangent to 3x. Then g of x is the tangent of x. This is the derivative of tangent of x is secant squared. H of x is 3x, so h prime is 3. So if y equals f of g of h of x, a triple chain rule problem, like the movie Inception, then y prime is equal to f prime of g of h, that's the yellow, times g prime of h of x, that's the green, times h prime. So I like that problem, just a triple chain rule. No, we had 4 total because we have 2 more. So this one's just a practice. Hey, we can still find the second derivative. That hasn't changed just because it's trig. So if y equals secant x, y prime equals secant tangent. That's just the identity. which you could do from 1 over cosine x, use the chain rule. Nope, use the quotient rule. So then the second derivative is going to be the derivative of the first part, which is secant times tangent. So the derivative of secant is going to be secant times tangent, and then times that original, or times that second part, plus the derivative of tangent is secant squared times the first part, such as how I do the product rule. And then I can clean that up. It's really a secant times tangent squared plus a secant cubed. If I have a secant in both terms, I'd probably factor it out to that. And the last one, so find dy dx. You have a sine function with a y value squared. You have this equal to some kind of cubic function of x. So just to show you that you can do this with implicit differentiation, you take the derivative with respect to x of both sides. So the derivative of sine of something is cosine of something times the derivative of the something. So sine of 2y squared is going to be cosine 2y squared. The derivative of 2y squared is 4y. The derivative of y is dy dx. Right hand side you guys get. And then I really just have to divide because there's nothing else to do there. Okay, so under 12 minutes, there's your lesson. I'll be available Monday through Thursday this week. We'll probably do the morning sessions on Mondays and Wednesdays and the afternoons on Tuesdays and Thursdays. Hope you guys have a great week. Good luck with all your e-learning. Let me know if you need any help with anything.